Well, we're just going to take another look at trig equations today. Now, remembering in the textbook, they may well have answers in radians, so be careful with that when you're finding your solutions, because we now have other ways of solving some problems. Now, cos 2 theta equals half, we saw ones like this before. We can say, oh, well, that's not a problem. What I'll do is I'll find cos, but instead of looking for theta in between 0 and 360, we'll look for 2 theta in between 0 and 720. So we'll go around the circle twice. We know it's in quadrants 1 and quadrants 4. So I want the acute angle of 60 degrees and 360 minus the acute angle. But then I'll add 360 to both of those because we're going around twice. Well, that's what 2 theta is. Divide by 2 and we get our answers for theta. And that's how we did it before. Of course, now we have other ways we could do it because we've got results for cos 2 theta we could use. So, same question, cos 2 theta equals a half. But instead I could go, oh, hang on, cos 2 theta, that's the same as 2 cos squared theta minus 1. Rearranging that one, I get cos squared is 3/4. So cos is plus or minus root 3 on 2. Well, that now means in this case I'm in all 4 quadrants. The acute angle in this case now is 30 degrees, but I'm in all 4 quadrants. So I'll get the acute angle, I'll get 180 minus the acute angle, 180 plus the acute angle, 360 minus the acute angle. Again, I come up with the same 4 answers. Which way would I do it? I'd probably still do it the first way, to be honest, for something like that. But it does give us an alternative approach. We saw ones like this, where 4 sec squared equals 3 tan x plus 5. And what we wanted to do is to get the actual trig the same. And we made use of the idea that, hang on, sec squared, that's the same as 1 plus tan squared, so 4 sec squared would be 4 plus 4 tan squared. We can create a quadratic equation. And this one factorises nicely. So either the tan x equals minus quarter or tan x equals 1. And solving the first one, second and fourth quadrants, acute angle, not an exact value, rounding off 14 degrees 2 minutes. And we have 180 minus the acute, 360 minus the acute. Tan x equals 1 is one of our exact values. We're in the first quadrant and the third quadrant. So we have 45, and in the third quadrant, 180 plus 45. Pulling that all together, we get our 4 answers. But now we have new trig identities that we can use. So cos 2 theta is 4 cos squared minus 2 sine squared. Now we've got 3 different ones we could use for cos 2 theta. Which one will I use? I've got a mixture of cos squareds and sine squared. I suppose one way I could do it is change everything to cos squareds. I could change everything to sine squareds. Or I could have a mixture. I decided to go with a mixture. And the reason I did that one is I can create a tan squared. Because I end up with 3 cos squared equals sine squared. Sine on cos is tan. So I get tan squared is 3. Tan's plus or minus root 3. So again, I'm in all 4 quadrants. My exact value is 60 degrees. So spreading that throughout the 4 quadrants, we get our answers, 60, 120, 240, 300. Again, personal choice. I mean, you could have, as I say, change them all to cos squareds, change them all to sine squareds, whatever you prefer, and it should still work, of course. Cos 2 theta is sine theta. Again, this one actually comes from an HSC, you'll notice. A choice of 3. I guess it makes sense to use the sine squared one for this one, seeing it equals sine theta. So let's go 1 minus 2 sine squared. Rearranging that, there we go. We got our quadratic. Is that one factorised? Multiply together? I think it does. Yes, it does. 2 sine theta minus 1, sine theta plus 1. So 2 possibilities. Sine theta is a half or sine theta is negative 1. Well, if it's a half, we're in quadrants 1 or 2. The acute, before I find the acute angle, if it's negative 1, that's one of our boundary values. So 270 is the only solution for that one. Okay, let's find the acute angle. 30 degrees, which gives us 30, 150. Putting all the possibilities together, 30, 150, 270. Whoa, that's an old one, 1992. 2 sine squared is sine 2 theta. Well, this one makes life a little bit easier because there's only one result for sine 2 theta, and that is 2 sine theta cos theta. Bring everything to one side and factorise. Common mistake here is to do what?
Divide by sine.
Yeah. If you divide by sine, you're going to lose this possibility that sine theta is equal to 0. So that's why we've always bring it to one side and factorise. So we either have sine theta equals 0, which is one of our boundary values, and sine theta equals cos theta. Remember, if 0 is a solution, 360 will be a solution when we've got our domain of 0 to 360. So I actually have 3 possibilities for 0. Sine theta equals cos theta. I'll make that tan theta equals 1. So quadrants 1 and 3, exact value is 45. 45, 225. And pulling all the answers together. Alright. So basically same sort of ideas we've seen before with trig.